Welcome guys to a quick little video, and in this video I'm going to show you how I have upgraded my power supply. My power supply used to have this series pass transistor, the NPN transistor 2SC5200. So this is the 2SC5200 that used to be the series pass, and the voltage and current regulation is being done by the LM317 IC, which is, you can see, quite junk. And after a large current spike that has decided to end his life, so that is gone. So I thought, why not make a new power supply, and in that I should add the constant current, constant voltage, or the variable voltage supply. So I have made this. So let me show you what is the design. So you can see the heart of the operation. We have the quad op amp LM324, and for comparing the output against the TL431, that you can see reference voltage that is standing alone here, the LM431. Let me show you first, because it's quite junky. You can see TL431, that is the TL431, that is the voltage reference that is going to feed the one side of the op amp, and the relative output voltage can be tapped and then be controlled by this potentiometer for variable voltage. And for the current operation, we have the 0.1 ohm shunt resistance, which is also being compared and amplified, and being related to the this cutoff transistor, that you can see, the NPN transistor, that is then pull down the base of the BD139 NPN transistor, which is then cut off the supply for the constant current system. So you can see it's a junk, quite mess, because I don't know how to create files on PCB Gerber or everything. So I have bodged everything so that everything can work together. And for the supply, I am using a 5 ampere transformer is connected in series. I have also put a switch to switch between 12 volt and 24 volt. So right now it is at 24 volt, so it can give output 24 volt at 4 ampere, because I have passed couple of series things so that I cannot blow the transformer, because you can see it's quite old. And let me show you the variable voltage operation, then I will show you the circuit diagram. So that you can see right now it is sitting at 4.6 volt, and here I have the output lead, and if I short circuit, you can see 3.77, 3.8, 3.9 ampere can be drawn. You can see quite you can see, you can control the let me show you the variable voltage operation first. So let me increase the, this is the multi-turn potentiometer 10k, and you can see variable voltage, and we can go up to 24 volt. Let's see how long can we go. So you can see we can go up to 24 volt as the supply came, and at 24 volt we can draw quite a lot of amps. You can see 3.8 or something, that is being limited by the shunt resistance and the potentiometer. So let's test the constant current feature, the current cutoff feature. So it's a multi-turn potentiometer. So you have seen previously the current stays at 3.88 amps. So let's reduce the amp first. Let's see, let's go over there and let's try to short circuit. You can see it's still a bit odd. Let's go over to more minimum current. So let's go quite low this time, and let's see if the feature actually works or not. You can see quite voltage is down to 0. Let's go again for increase the voltage at least at that threshold, because that uh, pulls down the gate of the NPN, and we still get 3.8 amps. So I have to check on that, but you can see something is being short circuited or something, so I have to check on that first. But you can see the variable voltage actually works, and let me show you the circuit diagram for my design. You can see the circuit over here. Here is all the parts list, and constant current do actually works because I have tested it. I don't know, something is being shorted. I need to figure it out. For this moment I am just showing you this circuit, and I will show you the uh, connection diagram over here. You can see, so basically the operation is being done by the TL431 voltage reference, which is being biased in such a way that that goes to the that goes here. You can see the variable voltage that feeds to the op amp, here the positive end, and for the feedback, we negative feedback, you can see non-inverting input and the inverting input, that is there to compare the two voltages, and that is then output the BD139 transistor, which is then pull down the in PNP drive, so that current flows this way, goes to the ground, thus following larger current to the output. And for current feature, that you can see, I have something messed up in this area, because otherwise it was working. This area, the current shunt area, that is being biased, and that is then being amplified and goes to the small little pull down circuitry if certain threshold current is being passed. So the voltage reference is being done by the this, and this is the comparator part that sets the voltage reference for the shunt, that is then goes to pull down the NPN, that is pull down the base and thus cutting off the power. So that is how this power supply actually works. So you can copy this, you can make your own power supply, small little 0 to 30 volt, 3 ampere is actually if you supplied, and you can modify all the parts to get more amperes, but make sure this part is, you have to figure it out by your own. I have used couple of resistance which are off value, such as this 330k, so I have to check on that, and something is being shorted because I have previously tested it, it worked. So that is that. So I hope you guys enjoyed this video. Peace.